Welcome, everyone. I'm Michael McCarthy, your instructor for the Harvard Blockchain course, and I'd like to welcome Roman Pavlov, Technical Director at SecureKey Technologies. Roman and I actually met last year at a MIT hackathon on identity, and I was loosely in his group sharing my ideas about identity, and he introduced himself and said, "Hi, I'm Roman, and you're doing it all wrong." So that's actually how I met Roman, and he had a really great idea. He's actually in the business. And I thought, why not invite him to this program for this year? So I'll just turn it over to Roman. He's going to share with you his journey in digital identity. And after his slideshow, we're going to open it up for Q&A, and feel free to ask anything that's on your mind. So Roman, welcome.
Thank you for having me, Michael. That's good to see. It's almost been just over a year, actually, I think, at this point. And yeah, we did participate in the computational law and blockchain event last year in Boston, and where we presented our solution in partnership with a company called Notarius. So my role at SecureKey, I'm a part of the office of the CTO, responsible for executing on our technology partnerships with our partners or clients. And so we presented our technology, which on its own is just a platform to share digital identity between different parties. And so our use case that we were showing off at that hackathon was how do you securely sign digitally a real estate deed between, let's say maybe there's two parties who are homeowners and they're looking to sell a house, but they happen to be across different, different states or in different time zones. And often that takes quite a bit of work to get that done. And with our technology, it is a fairly easy process, right? So we'll show some demo videos of a few things. And just maybe to give you an overview of what digital identity is, I'll go through a few slides, just kind of briefly explain who SecureKey is. We're not really a household name. And what kind of work that we do in our journey, I guess, overall.
Do you need a hand with the share button?
Nope,
oh, there it is. Yep.
We have that.
It's just to hit play from start, and we're good to go.
Right.
There you go.
A little bit about myself and it's our brand. The new product that we have is called Verified Me, and a little bit about the company called SecureKey Technologies. We are based out of Toronto with offices in office in Canada and a couple offices in the United States. And what we do, we build identity networks that enable people to essentially exchange identity attributes online. And we have a network in Canada, and we're building some networks in other jurisdictions as well. We're backed by quite a few investors and strategic partners, pretty much every major bank in Canada and some credit unions, some telcos, IBM, and credit card companies. So what identity really is, there's several parts to it, and the core components is what you know, and usually that we refer to as a password, and what you have, and that could be a second factor, either your phone, or it could be an RSA token or things of that nature. And what I am, and in that case, that could be a biometric, right? So that could be things like Touch ID or Face ID these days, right? Sometimes it could be a computer reader for your fingerprints and so on. So what this allows you to do, instead of just having username and password, is to build a more comprehensive multi-factor identity of a specific user. And now, to build out a network, it takes quite a bit of investment. We've raised $30 million from major banks in Canada. Some of them are active in the United States, so you may be familiar with TD Bank and maybe Bank of Montreal. They do have some partnerships as well, and so is RBC. That gives us access to over 90% of population in Canada in terms of market penetration. And they are the core members of the network. So each bank would be running a blockchain node. Our system is blockchain based. It's built on IBM Hyperledger Fabric. And so just to kind of give you a brief overview of what the network looks like. So you would have essentially a consortium, and in this case, these are just banks, at least in our case in Canada. And you would have different parties, right? It could be finance sector, again, either banks or political companies, third-party lenders. It could be government, federal or provincial governments, could be a municipal government as well. Utilities, in this case, it could be a telco to maybe providing some information on your address or how long you've been on the specific address for, or maybe it could be your cell phone provider to provide your real-time location in case if you need to, or maybe to prove that your SIM card hasn't been changed for, say, 6 months or a year, and to make sure your phone hasn't been stolen, somebody just swapped out the SIM card in your phone. And of course, the probably largest market would be companies who would consume that identity. And in that case, that would be e-commerce, rentals like Airbnb, healthcare portals, places like eBay or Amazon. In our case, in Canada, we have a company called Kijiji, a division of eBay, and they would be looking to secure maybe higher value transactions like cars, right, to prove the identity of buyers and sellers to make sure it's a legitimate transaction. Now, as you grow this out, right, you could add, I mean, the system is scalable and you can add many different kinds of companies and use cases, right? At the core, it really is just a data broker, a decentralized data broker with no central honeypot of data that you could just break into and take something from it. Like we really retain no information whatsoever about the user. And in particular, a specific feature of our design is something that we call triple blind privacy. And what that means is that no single party would be able to track a user throughout the system. So let's say if you were to log into some kind of a healthcare portal, perhaps you don't want to know, don't want your mortgage lender to know that you're going to, let's say, a cancer clinic or something of the sort, right? And that privacy promise is built into our design, right? So that's one part of it. And because it is a distributed network, right? Let's say if it so happens that one specific party decides to turn off the connection, it does not affect anyone else, right? And this way, it's resilient to all kinds of attacks. There's an essential point of failure. You have certain guarantees of continuity of business. This also allows us to comply with some fairly strict regulation in Canada, given our privacy laws, that we cannot track users across a network, right? So it's not only a feature, it also allows every party in our network, like governments and banks who are heavily regulated, to actually participate and to provide this to the service to users. Now, so when we talk about those data elements, your attributes or claims to call it an identity world, right? It could be something very simple, like your first, last name, could be a phone number, duration of how long you had the account. It could be maybe your driver license number. And again, those are digital assets that we share through our blockchain. They come from different providers. We call them digital asset providers. And that could be your either government-issued ID, like a driver license. It could be information from your bank, right? Just your first and last name, because the banks have a fairly strong a process to vet who the customer is. And so there is some reliability you can rely on the bank, right? And then you can extend it with, say, a government ID. You can get an additional information from the telco that you're with, and maybe also some credit information. Let's say if you're applying for a loan, or maybe you need a second piece to perform a know your customer check. That could come from a credit bureau. So it's a fairly flexible system. We can exchange all kinds of information between different parties. Now, the important part here is that the user is always in control, right? So nothing is exchanged without your consent, and you approve every single transaction. So this way, there is no exchange happening behind the scenes unless you have authorized it. So every time there's a request, you have an app that will allow you to process a specific request. You can review the details, what exactly is being exchanged, and who's requesting, and what's the reason, and so on. And that way, it's real time. It's approved by the user, and the value of that is, of course, is a lot, I believe, higher than some kind of a static database against which you can just check, okay, if does all of this match with the static file that we have in you, right? So it's a fairly comprehensive solution in terms of identity, and you could expand it perhaps into other use cases as well. I mean, you could essentially transfer any kind of information, and that's something we'll probably be looking to do in the future as well. But identity is what we do primarily. So recently we have been in the news where we've done proof of concept with Canada Revenue Agency, which is equivalent of IRS in the US. It's essentially a tax agency at the federal level. And we've done a couple of use cases. Right? So today we have a service in production. It's been in production for several years. We call it SecureKey Concierge. And what that is, you can log into CRA, Canada Revenue Agency, with credentials from your bank. So it's essentially a federation of your login. And what that allows CRA to do is save some costs on administering those accounts, right? Because you don't log into the tax agency too often. People forget what it is they have to call them. It costs them quite a bit of support costs. But with your bank account, you deal on a daily basis. And it's a password you're probably less likely to forget. You probably use it a lot more frequently than you interact with the government. And so that is what we have in production today. It's not a blockchain service, but and it's more of a login federation system. What we're looking to do with this new product, Verified Me, we've tried out several different use cases with the federal government of Canada and the provincial government of British Columbia. So the use cases would be is to register and create an account first, in which case there'll be two pieces of ID leveraged, some identity information from your bank and something from the government of your province, state. Right? So it would be like your driver license information, they confirm your address and so on, and the bank proves your address and account number and things of that nature. Second case, you could set up a direct deposit, so that's where your tax refund would come directly into your bank account, right? Again, you get two pieces of ID, and the bank provides your account number, so this way your refund can go directly to your bank. Now, the third use case, and probably the most interesting, is because currently all this infrastructure for the governments is essentially just a cost, right? But what the system will allow them to do is to mobilize the data and gain some actual revenue from it. So let's say if, not necessarily your bank, but could be any other institution that wants to lend you money, they probably would like to know how much you made last year. And easiest way to do that, most secure way to do that is to get it directly from the government, which today there's quite a few things in the way. They cannot just share the data easily with just anyone. So it boils down to paperwork and just some photocopies being exchanged between yourself and the banks and some pay stubs. And it's not real time, it's time consuming, and it's not always accurate. So what this allows them to do is that you can do this in real time at the institution, or even remotely. You could do it with while you're applying online. So that's one of the ways for either government or any other provider that has some information about you to leverage the data and gain some revenue instead of just being a cost. The same goes for banks or provinces or any other data provider in our network. So this is going to be a quick demo. So a quick demo of what this actually looks like. Just put it over. Right. So this would be this is basically an app on your phone that you would use to interact with the system. Right? So just a landing welcome page lines up the available banks that support this, and then you can proceed and sign up. So this is a sign up flow. Right? Outlines the steps that you would need to take, select the bank, sign in with them, and then verification is complete. Right? Gives you the list. You click on the bank that you're with. I'll try my bank in this case. And what happens next is it actually goes to the bank's website. And that wouldn't be SecureKey's website. That would be the, say, website of TD Bank or any other bank that is in the system. So that way we actually are not even seeing your login, or we're not, none of the information passes to us. It goes directly to the bank. And so once you log in, the bank will display some information about you. And those are the claims we spoke about, right? So you will have your name, address, your phone number, email, and so on, right? So those will be the basic attributes or claims about your identity. Right? And once that's done, you create your profile, and it is now in the app, right? So you've been verified, and there will be some next steps that you can do. And this is just a mock-up of what things could look like, right? So you could do a credit check, you can sign up for some services, things of that nature, right? So on the next slide, what we'll do. Any questions, by the way, so far? I've went through quite a bit of material, so maybe anyone has any questions in the meantime that we can answer before we go to the next slide.
Feel free to raise a hand if you have a question. Joanna, hi, you're on the air.
Hi, yes. I think this is really a great application. I'm very impressed. And I was wondering a few things. What is software did you use for design? Did you use Sketch or Marvel or something else? And also, what software are you using? What computer languages are you using in the background systems?
I'm afraid I can't share maybe that level of nitty-gritty details. So we do use Hyperledger Fabric as the core foundation for our system. And Hyperledger Fabric is written in Golang. It's an open source project supported by, there are many members of the Hyperledger Foundation who contribute to that. One of the contributors is IBM and SecureKey, and there's some other companies that contribute as well. So that's the core system. Right? There are mobile applications, of course, right? So those will be native apps on Android and iOS, and with those, you know, it's essentially the regular tools that you use for a native app on a specific platform. Right? I mean, there's no secret sauce or anything else. I mean, we do use Sketch for UX design, among many other tools. So there's quite a few things that go into making something like that, right? It requires quite a very large effort because it is a new product that you have to build from scratch. It's not just putting pieces together, right? So there's quite a bit of iterations and tries that you have to make before you get to the final result, right? So I mean, we went through a few different phases of trying out different things, and that's what we settled on in the end. Hopefully that answers your question.
Thank you.
I have a question, Roman. So when do consumers first meet you? Are they introduced to you because they have a bank account, or do they meet Verified Me directly? What's their first touch point with your group?
Well, because it is a consortium, right? It is probably banks that will be the first point of contact, right? And often, and this is actually what we're going to show you in the next demo. You may come into contact through some other party, right? So, for example, let's take a look at that. Okay.
If your screen gets stuck, you might need to unshare and then share again.
I had it on pause. So, can you see it now?
Yep, Moon.
Right. So Moon Life Financial. So that was a video we've made with Sun Life Financial, our fairly large insurer based in Canada, and they're one of our partners in our network. But in their case, they're not yet providing data; they're just consuming the identity data in case if you'd like to sign up for an insurance product of some kind. Right. So in this case, right, you could navigate to their website. And if you decide to get some sort of a product, and you would need to sign up for it, right? You would need to sign in or create an account, and you could either just fill out the form like you normally would, right? Fill out all information, your address, everything by hand, which is fairly difficult to do on your mobile device, or you could download an app, Verified Me app, to allow you to sign up quicker, right? So in this case, we, of course, decide to use the Verified Me app, which will either prompt you to install it, or if you already have it, it will trigger the app for you. Right? If you don't have it, it will open the App Store with some information about it, and how you can get the app. But in this case, we assume that the app already exists and that you have it on your phone. Right? So in this case, in addition to your base profile, Sun Life would like to get your phone verified to make sure you are signing on from the mobile device that you own and that phone number really does belong to you. Because in case they have to call you back, they want to be sure they're calling the right person. Right? And you proceed with the data sharing. And at the very final step, before you actually submit it, the app will tell you what you're going to share. So the base profile is that same attributes we've seen from the bank, the name, address, date of birth. And phone verification is, well, it will verify your phone number that you have it attached, that specific device you're working on right now. Right? You can review specific attributes by clicking the Review button, or you can go ahead and submit this to Sun Life. Right? And at that point, the mobile app will put you back in a session with Sun Life, and we'll say, okay, you've been verified. We've got your name, got your address, date of birth, and we've got your phone number as well as the email from the bank. Right. So you've got some attributes. The account is created. It's a lot quicker that you can do just by filling out the form, and it also provides a level of assurance that it's real-time information from real-time sources of the data, namely the bank and the telco company. Right, so, and what you've seen right now, this is actually live integration with those sources. Right? So there's actually a live connection to a telco, and live check going in the background takes maybe a few seconds, and a few seconds to get your data from the bank, and there you are. Right? And now you have your account set up. You can just enter your password, and now you're in your either retirement or insurance account with Sun Life. So that's what it would look like if you were to use this app in the wild, right? And of course, the partners that operate the network, the banks, right? There is, of course, for every transaction, they retain some revenue for transaction fees. So they, of course, will be also marketing this to their users, and you may encounter uninvited as well, just like in this example. Several different ways of getting access to it. Right? So that's pretty much what the system is, and we can talk more about. I can field more questions, so we can talk more about identity in general, things of that nature.
So feel free to raise your hand if you have any questions. I have one for you, Roman. What data are you exactly putting on the blockchain?
Okay, so keeping with our privacy commitment, right? We cannot really put any data itself. So your real data does not actually hit the blockchain because it is distributed and everybody could see it. Into the blockchain, there is certain proofs go into the blockchain, certain events that are anonymized, right? So you cannot actually derive some information about any information about the user from that. The point of blockchain in our system is really to serve as a coordination mechanism between different parties to make sure that we've got legitimate members of the network sending legitimate information. The certain user is authorized to, say, continue the transaction. Like, for example, a certain user may not be allowed to use it anymore in the future, or you want to disable their account. Well, let's say they may call their bank and say, look, I've lost my username password or whatever else, and it needs to be suspended. So in that case, you wouldn't be allowed, that account would not be allowed to proceed, right, in case if it's stolen or compromised, right? So there's a lot of information that goes in there that's nothing to do with the user's personal data. And the way the personal data is exchanged, what happens in essence, essentially the system sets up a session between the members of the network that's encrypted. The data from one, say from the supplier of the data is encrypted, and then it passes through to the receiver of the network with the network itself being in the middle, so you cannot actually tell which member is sending directly. You just know that, okay, it was category, from such and such category, say a bank or a credit bureau, and they're supplying you with such and such data, but the source would be concealed. In some use cases, perhaps they would need to know who the sender is, and that would be up to the user to authorize if they want to send the name. Let's say if it's TD Bank that's sending this information, right? The user can agree to that, and that will be shared. And again, that goes in the same process. It's encrypted and passed to the network, but it is not retained in the blockchain itself, right? The blockchain itself is more of a, the best way to describe it would be as a mechanism to coordinate this process and to ensure every transaction is legitimate.
Okay, thank you. I see Paul is with us. Hi, Paul.
Hi there. Hi, Roman. Paul Quigley. I'm one of the instructors along with Michael in the program. And so let's go back to the blockchain transaction itself.
Right.
So you're coordinating data outside, so you're off chain. I've got my PHI or my PI off chain.
Yeah.
You're hashing that, and you're placing the hash onto the blockchain.
Of course, every transaction. I mean, whatever you have a packet, right? PI would be, well, you cannot just do, of course, just hashed. It would be, of course, salted as well, right?
Okay.
And at that point, it is anchored. There's a link to that created into the blockchain itself. It's a little bit more involved in that, right? And I can't really go into that deal into the architecture. But what we do, we leverage there's several blockchains that we leverage, right? So there would be like a ledger that's, you could say, the root or main ledger, right? Mm-hmm. And over there will essentially be just anchoring information, right? Then you would have ledgers that pass the information themselves.
Between ledgers?
Well, I mean, there would be the main coordinating ledger, right? Let's call it that way, and then there would be other ledgers that are sort of a sub network of sorts, right? Mm-hmm. So there's a little more than just than a trivial single blockchain where you have nodes sending information back and forth, like you would have in some more perhaps, I mean, everyone has heard about Bitcoin and Ethereum, right? I mean, where you have this one single chain and everything happens there, right? And in our case, it is a private chain, right? So right. Parties are vetted. And so, but we do have that core ledger, right? That coordinates those transactions. And then you would have sub-ledgers where information could be exchanged and so on, but it does not remain stored. It's discarded.
Okay, so from a diagrammatically, mm-hmm. It's a permission-based network. By virtue of the fact you're working with Hyperledger, it's going to be permission-based anyway. It's not going to be a public chain.
That's right.
Right. So every partner has their own ledger, and then you have a master ledger which they coordinate with. Because otherwise, the workflow that you're talking about, when you said you're using it as a coordinating mechanism, and the other parties can't see what, say, Bank A has, because that's in Bank A can see what customers have. So you're using a master ledger to coordinate activity, but you're all staying inside the permission-based system.
That's right. The entire system is permission-based, right? And there is a court. It's difficult to do with just a single ledger. Because,
right.
All right. So you have to have mechanism to exchange information off-chain, but then we do need to have audit trail for that as well, right? We may not want to retain it, but we want to maintain some audit, right? So there will be like an audit trail chain and things of that nature.
Okay. No, I'm going through this with you because what's happening is at this point in the lecture series, the students are learning about blockchain.
Right.
I would say kind of in a linear fashion. Transactions, hashes,
right.
kind of the Bitcoin model, right?
That's right. That's right.
But I think that the important part of this, and thank you for speaking to the group, the important part of this is that in the business context of how do you actually make it work, we've got a permission-based constellation of parties who are in some ways collaborating, and in other ways they're competing.
That's right.
Right? How do you continue to use the blockchain in an ecosystem?
That's
what you're
right.
describing is really the need for the party to have its own ledger, and then you're coordinating across ledgers, but you're in an ecosystem that agrees to collaborate.
That's right. But and it's a good, actually, I'll just touch on the competitive side of it. Even for banks, right, they would not perhaps want to, say TD Bank would not want to know what Royal Bank is doing.
Right.
Because that could be considered a competitive, a collusion maybe, if you will, right? They really don't want to see that information. So it's one of the other reasons why privacy is so important, because you cannot just show the other bank, okay, look, we're doing this many transactions with that many users. They don't want to really see it. Or what kind of information is being transacted. So it has to remain as private as possible. And that's another big driving factor for why privacy is so paramount. It really is the only way to get, I think, collaboration going in a context where you have parties that really compete in business as well, right? We have to collaborate, but there is some competitive concerns also.
All right, thank you.
And Joanna's next.
Yeah, hi, this is great. Question. So basically, say for an example, if I have a customer, Katarina, and she has a bank account at 2 banks, but she's doing this process. So now those 2 banks don't want to share information with each other. So do you assign Katarina customer number 100, for example, that all the partners in this chain have access to? So Katarina is always called customer 100, whether it's Bank of America, Sovereign Bank, Toronto Dominion, etc. And then when it gets to the request goes to that particular bank with customer 100, now they have translate customer 100 to their own Toronto Dominion. Oh, she's customer 1 here. Do all the processing on their system with customer 1. Then ship it back as customer 100 with the result, but only with the customer number, no identifying information, for example?
Well, no, the banks do share identifying information, which is, the point of the system, right? You do share your name, address, things like that. That is your personal information. We don't actually have a user ID that's global on the network, because that would allow you to track the specific user. So what happens, every party in the network receives a different pseudonym for that user, right? They will have every single party in the network, say TD Bank and let's say Sun Life, for the very same user, they will have different unique IDs. So this way the user cannot be tracked across the network. But yes, there's a translation mechanism involved, right? So the user number such and such goes to the bank. They have to map it to the users on their system, on their book of record, grab that information, encrypt it, send it back to the network, and then the network goes, okay, this is for user X at TD Bank. We need to send it to the user Y at Sun Life. The routing occurs, and then the decryption occurs at Sun Life, right? And then Sun Life gets plain text attributes, so your name, your address, and so on, at Sun Life. So that would be so it's a little bit more involved than just having a unique number. It is something that we do currently with our existing service for the federal government, where you log in with your bank to the government. And there, yes, we do have a number called MBUN, meaningless but unique number. So it is essentially a random number, and that's an identifier in the system for that specific user. So that would work in that model. But the reason why we do that in that older model, and we don't do it in our Verified Me product, is because in that service, we only essentially log you in. So just a login service. There is no private information being traded. As soon as you begin trading private information, it needs to be at some point decrypted. And once it's decrypted, that party would have access to it, right? They would see what it is. So if you have a central hub that does this routing, the hub would see it, right? And we would have to design something that there is a central hub that can obtain that information. And what we came up with was this distributed model in which blockchain we leverage the distributed nature of the blockchain to create a hub that's not really a single party, but a network, right? And there is a mechanism where transactions don't flow to that same party every time, right? So you cannot, even if, say, you have these blockchain nodes, right? But they cannot even correlate all transactions because they're randomly assigned to go through different nodes at different times, right? So there's more of that routing that happens in distributed fashion with blockchain, versus if you have a single identifier, you can do like a login, but you wouldn't be able to do exchange of private information in a private manner. And that's why we decided to leverage a blockchain solution.
Right, because that would violate the Canadian law of not transmitting across networks. And that's why you can't do it?
Well, I mean, it's... it's more than just that. I mean, there is many different ways to comply with regulations, right? And different companies do it in different ways. We try to be in a position where we don't have any personal information at all, right? So even if you were to break into our existing system, there's really just random numbers that have no, I mean, you wouldn't be able to get information out of it at all. I mean, we wouldn't be able to compromise ourselves even if we wanted to, right? So that's the design principle that we have. And that, of course, makes it a lot easier to comply with all kinds of regulations, because as soon as we touch personal data, then there's a whole bunch of regulations attached to that, right, that we have to comply with. And that also makes it a lot easier for us to comply with it because we simply don't have it, right?
And Rusol has a question. I just unmuted you, Rusol.
Thank you. Thanks, Sean. And thanks, Roman. Roman, actually, you answered my first question when you did that little demo. So thank you very much for that. My question is, so let's say I downloaded the application. I logged in with my Chase account. It's got my profile. I did some sort of a transaction. So if I use it next time, do I still have to authenticate again because there is no identity profile saved in the blockchain, as you said?
Oh, okay. So yes, we don't actually save anything on the blockchain or even the app, believe it or not. There's actually nothing personal stored inside the mobile app as well. And you have to be careful when you say authenticate, because there might be several authentication events happening here. When you have to log into the bank, right, and establish that session with the bank, in the demo that we showed, right, that's, okay, there's a username and password, and it's really for demo purposes to make it easy to comprehend, right? Because if you just do Touch ID and it's in a blink of an eye, you're logged in, it's too quick of a demo and we just don't catch the event occurred there, right? But with many bank apps, as I'm sure you're familiar, you can have Touch ID or Face ID, right? So you would authenticate with the bank just by doing that, right? And that speeds up, of course, things. Of course, you don't have to enter your password. If you want to, you can always use your password. The session, when you log into that bank, the session is good for a set amount of time, right? So you don't have to do it every single time. Let's say if within so many minutes, say 10 minutes or 5 minutes or whatever the consortium of banks decide, because really it's up to them, right? It's really their choice. they would agree on a specific number of, say 15 minutes, for example, right? So within 15 minutes, you would not have to log into the bank again, right? So you could share this thing multiple times from different sources, and you would not have to log into the bank. However, if that timeout occurred, then you have to log in again, I think it's a fairly long window of 10, 15 minutes for you to perform transactions, in case even if you have to do it multiple times for whatever reason.
Okay, thank you. My next question is, do you think that this sort of apps can be in the future used as your single point of identity proof to log in into different things such as your Yahoo Mail, your, any kind of account you have? So instead of having 20 or 30 passwords, you have that one single point of identity proof?
Of course, that is the goal, to build an identity standard that maybe is not only national, maybe even global, right? Because there's so many, just the amount of passwords people have to deal with these days today. It's just overwhelming, right? You have hundreds of passwords, and every website has different requirements. Need to be this long. You can have this or cannot have that. It's difficult to keep up, right? And there is no password per se, right, in this entire system, right? You have the entire thing hinges on the security of your bank account, right? And the bank knows, look, you log in from that app. We know it's a security, verified me app. Logging with their credentials, and banks, they have fairly well thought out and established infrastructure and process to deal with a lot of fraud scenarios, right? So once you log in, it's not just that your password is correct, right? They verify a whole bunch of things. Do you normally log in at this time? Do you normally log in from that specific location, from the IP address you come from? There's a whole bunch of fraud metrics that they throw at you during that quick login process, right? So it is actually a lot more secure than just having a single password, or even having a multi-factor authentication when you have, let's say, your login plus your, let's say, a token with a one-time password that you enter, right? So there's a lot of benefits, and we do see it as taking a good chunk of the market. For sure, I think high-value transactions are definitely a good fit. But even, say, we're talking about like Yahoo Mail, for example, right? You probably don't need, information from your telco, your government, and the bank just log into your Yahoo Mail. So for that, we envision a lighter use case where you simply get an authentication event that this user was able to identify themselves with the bank, and here's your proof of that occurring, right? And again, we're talking about those different IDs for, so Yahoo Mail would have, instead of X, Y, and Z, they would have like Yahoo Mail ID for that user. And every time you come back, they would get that ID, and it would be similar to logging in. Like, I'm sure you have seen Google buttons or Facebook buttons. It would be a similar process to that.
Yeah. Well, thank you very much.
Paul?
Roman, the question I had was, you were talking about the multiple passwords. Are you in this standard? One of the things that I've seen is each of the blockchains are proclaiming their own standard. And there's no standard. There's no standard.
Okay.
So the only thing I've seen that comes close is the OpenID standard.
Yes.
Are you guys complying with that, or adopting it, or asking to modify it?
Everything that we do leverage standards as much as we can, right? And OpenID is a part of our technology stack, right? So authentication events that you see with banks, those of course are standard, right?
Right.
That is OpenID. Now, for blockchain themselves, overall, there is no standard just yet. You're absolutely right about that. And it is an issue, because if you'd like to build an industry or an ecosystem around it, you need to agree on a certain set of things people call standards. You have to agree on certain what things will look like. How do we enable interop between all these parties? And there is some work that we are participating in. It's called the Decentralized Identity Foundation, and we are part of that, along with many other companies, trying to work out maybe a common standard that would have to do not so much with blockchain, but with decentralized identity standards.
Yep.
Something we do work actively on it towards a common goal, but we do believe a commercial, we need to have some kind of commercial traction before I think standards can become valuable. Because if you don't have really a market for it and that's not well developed, I mean, you can have a standard, but it doesn't really get you very far, right? So we decided to build something first, and we can always adjust architecture or make changes if we have to. We believe our system is flexible enough to handle that, right? So we've built that out first to get some interest, to build out the seed, that kernel of the market, to start to grow it, right? And when the time comes, we can maybe work out some more standards towards specifically the identity part. The blockchain itself, I don't think there'll be much of a standard. I mean, technology changes very quickly, and it really isn't. It's not necessarily for that to be a standard. Like, it doesn't really matter what computer language you use to build out the system, right? Or what type of database that you're using, if it's Oracle or if it's Microsoft SQL or whatever else, right?
Yeah.
That will remain there, and it's really just a building block, which doesn't have to be a standard. On the other hand, we do, I mean, like I said, we do some active work with the DIF.
Okay. Yeah, the reason I asked that was that part of that is that when you compare the growth in the blockchain economy with the internet, what happened with the internet was there were transaction requirements, standards, and other elements like TCP/IP, which were all agreed to as the internet started to grow. So you had this modular mechanism which allowed scale to happen at a much faster pace. What we're seeing in this economy or in this market is that because there are protocols and everyone has their own protocol and everyone has their own standard, I know you're laughing already, but there's this, I mean, we work with this all the time. So the problem is you end up with a blockchain specific set of protocols, and then the challenge now is the interchain. One of the things I'm part of the Hyperledger work group. So I bought into this model a long time ago in terms of when it started. So that's the challenge I see as you're trying to bring things to market and you're trying to scale. What occurs is you've got to now negotiate across chains, and it actually in some ways slows down adoption because you're not willing, if you're a company, do you want to make an investment in chain protocol A, B, or C?
I mean, look, in terms of having multiple different blockchains with completely incompatible nature, I mean, I think that's expected. I mean, the industry in such early days that there is no. It's difficult to say. I mean, it's difficult to commit a specific model because, and I think a part of it why we decided to build technology first is because there's simply nothing proven, and you would need to prove something in the market first. Once it gets established, you can then move on for that to become a standard, right? But I think it's a lot of it has to do with the sector being fairly new. Bitcoin is only 10 years old now at this point,
right?
And the commercial deployments are maybe several years at best, right? So, I mean, it's very young, right? The field is very young, and I think might be even too early to think about specific blockchain standards. And I think some of them will definitely remain as they are without much changes. I mean, you can build certain bridges between them, and I think that's probably what likely will happen. It's a lot easier, I think, to work on that angle in the permission sphere, right? Because you got a consortium, you've got parties operating it, and you have a set of people you can discuss it with. Whereas in case of you've got, things like Bitcoin, I mean, the stakeholders it's a public network, anyone can join. It's very amorphous. There is no circle where you can have a discussion, right? And that's where I think permission will probably become more or less standard at some point. We'll figure out certain ways. I mean, what sticks in the market and what doesn't. The DIF is doing work on specifically identity part of it. But let's say those public chains, I think they will probably remain in, I guess, with varying degree of consistency of how they became. They seem to be very sticky, right? So the changes don't seem to be very easy to make, right? I mean, once something is deployed, it tends to remain more of the same, really, right? I mean, and they're very difficult to deploy new changes or convince everyone to upgrade and so on. So there's that challenge with public networks. And I think they will probably remain a challenge as long as they're around, and they'll probably become more slower to change and adopt new technologies. But why I think there's a degree of flexibility there, I think there's a varying degree of decentralization. So some of them are a lot more decentralized, and some are really controlled by a single or maybe a handful of companies, right? And those will probably see more changes.
Right.
Right. So that'll be probably my view. Yeah.
Yeah, thank you.
And Joanna.
Hi again. So I noticed on your list of strategic partners, the only non-financial institutions listed were Intel Capital, which may actually be serving as a semi-financial institution, and IBM. So is IBM serving as a financial institution with the IGF, IBM Global Financing, or are they serving as the Hyperledger partner, or more than that? And secondly, usually IBM wants to do everything, so I find it very interesting that they let you do this. And was there a particular reason why IBM chose not to do this part, or did you already get the contract before that? Thirdly, are you considering branching out to the US or to other type of industries? And fourthly, since there's no real standards yet, and you're the first one in, maybe you can become that standard and get grandfathered in. So I just want to see what your thoughts are on these things as the expert.
So first off on IBM, IBM is our technology and business partner. Right? SecureKey is a much smaller company than IBM. IBM is enormous, right? And they have a lot of partnerships with other institutions that we can leverage, right? So it's a technology partner for sure because of our Hyperledger work, and of course our business partner as well, right? And now when it comes to different industries in the United States and so on, I mean, it will be a safe assumption to assume that we're working across many different jurisdictions. We actually working around the globe actually at various stages in trying to develop our networks. Something global probably would be, I mean, over between borders probably would be a stretch at this point, but I think we're making good progress towards some national networks. And I'm not sure what you mean when talking about different industries. I mean, identity is our core industry, really, just digital identity itself. It can be leveraged though in many different sectors. It doesn't have to be finance. It could also be healthcare, for example, legal industry or real estate, like in our hackathon that we've done in Boston with Notarius. So Notarius, just to briefly touch point on that, is actually so Quebec is a civil law jurisdiction where notaries have a little bit more involvement in the legal profession that they do in common law, right? So they're not just there to certify a signature; they actually prepare and structure contracts, and they're very actively involved in real estate transactions in Quebec, right? So that would be for sure one of the sectors. And the system, the way it's built, is very flexible, we can handle. And one other thing that Notarius does, they actually prove professional status of a person. So if, say, a bridge were to be built in somewhere in Canada, the blueprints were likely to be signed by their technology digitally. And at the time of signing, they also ascertain that this specific engineer is in active good standing with this specific certifying body to make sure they can actually legally sign that blueprint. And that's something, that specific status information is something we can easily transfer to our system. And that's probably another use case we'll try to leverage as well to prove in real time your professional status. If you're a lawyer, a notary public, an engineer, doctor, things of that nature. Right? So I think it's the set is quite, it's still it's a wide open set for us. It's new. And in terms of us becoming a standard per se, I mean, we're looking to collaborate with partners in many different jurisdictions, and it's difficult to, I think, become a global standard off the bat, because everywhere the standards are so different. So there'll probably be slightly varying standards, and maybe the centralized identity foundation can help with having a single set of standards. But how far that will take us, I mean, I think it remains to be seen. It's very early in the work still.
So, Roma, we really appreciate the time you spent with us. We only have 3 minutes left, so I'd like to pop in the final question, which would be a total layup. What do you see for the future? What are your hopes, dreams? What do you think is going to be happening? Crystal ball time.
Yeah, difficult to say. There's a lot of work going on, but look, we obviously looking to establishing a firm footing in our home jurisdiction in Canada, right? Getting this off the ground, getting governments and private sector to work together, and then using that success to leverage into maybe slightly larger markets. We're talking about United States, Europe, maybe some work in Asia. There's a lot of opportunities, but we look into a lot of, I think, quite a bit of busy years ahead of us.
Good for you. When you want to come to the United States, we'll all show you around. We'll introduce you to all our friends.
Yeah. So thanks for having me.
Thank you so much for your time. We've recorded the session, so I'll send you a copy of it before we distribute it, so you can make sure that you're comfortable with us sharing with the rest of the class. And thanks for teaching us about digital identity. You're a part of the future, and we appreciate that.
Okay, you're very welcome. Thank you for having me.
Okay, take care, everybody.
Thank you.
Thank you.
Thank you.